Today let us discuss about FAJAN's rule. FAJAN's rule is a very important topic to be considered for JEE and NEET. Now what is FAJAN's rule? This rule generally talks about the covalent nature in the ionic compound. What is ionic compound? The compound which is formed by the bond of ionic bond. What is ionic bond? That is the complete transfer of electrons from one atom to another atom, where there will be a development of charges. For example, Na donates one electron to chlorine and chlorine accepts that one electron, and Na gets the positive charge and chlorine gets the negative charge, and that particular compound is called as ionic compound. And how come the ionic compound have a covalent nature? And this is now discussed by this FAJAN's rule. Here the FAJAN's rule talks about, or the FAJAN's rule says that no ionic compound is 100% ionic. He says that no ionic compound is 100%. There will be a distortions. They will have the covalent nature. How? Now this will be going to discuss in this FAJAN's rule. So to understand this FAJAN's rule, there are some set of rules which we are going to discuss now. Before going to know about the set of rules, now what does the FAJAN's rules generally hold on? It will hold on something called as the term polarization. Okay? Polarization. Okay. Now what is polarization? Polarization is nothing but that is a phenomenon happening between the two charges. What are the two charges? Positive and negative. Polarization is a phenomenon, or that is the effective energy between the two charges. Okay. Now what happens? Let us talk about something. What happens in the atom? Generally, we all know that the structure of atom consists of a nucleus and the shells. We know that this is the innermost electron and this is the outermost electron. And here the nucleus have its effector on the electrons, which means the extent of this nucleus power will attract the electron towards itself, whereas it will also have the power of extender to attract the electron towards itself. This is called as nuclear charge. We all know that. So, point to be considered here is, we all know that when less size of atom, more nuclear charge. Yes, we can consider this because, for example, to understand this statement, less size of atom or small size of atom, then it is more nuclear charge. How? See, let us consider here. Now this is a small atom. It is having two shells and it is having one shell, where the distance between the nucleus and electron is very less, and hence the nuclear charge is more, which means it will attract more. So this is called as something called as the nuclear charge. And when we talk about the ionic compound, now let us come to this FAJAN's rule. Okay, when we talk about this ionic compound, we know that ionic compound, for example, let us say NaCl. Okay, here you see Na plus and Cl minus, and you can see that positive atom and negative atom will be present. Okay, the positive, the cation. Okay, now let us say cation and anion. Okay, so this cation and anion are now held into one position. And if you say polarization can happen here also, how means here the positive and negative charges are there. So this positive charge will make distortion in this anion, which means the positive charge here, or here the nucleus present in this cation, will exert its energy, or it will attract the electrons present in the anion, which can distort the electrons in the anion. Okay, so this is what we need to understand here. To understand it very simply, I will show you a small picture to understand this one. Okay, so this is a cation, and if I say the anion is like this, and due to the polarization, so what happens here is the electrons are distorted in the anion. So this is called as polarization. Now let us go deep into this point. Now something called as, we need to understand two terms here. The first term is polarizing power. Polarizing power. Now what is polarizing power? Now polarizing power is nothing but which is talks about the property of a cation. Okay. What is polarizing power? The ability of a cation to distract the electrons present in an anion, or let us say to pull the electrons in the anion. That is called as polarizing power. Okay. For example, if I say I have more power, how can I say I have more power? If I lift more heavy weights, then I consider to be have more power. And as in the same way, to understand the polarizing power, the cation, if they attract more, they have more polarizing power. We will see what are the factors next. Okay, the next one, polarizability. What is polarizability? So, what is polarizability? This is the property of anion. Nothing but, so when cation is pulling the electrons towards itself from the anion here is able to give the electrons to the cation, and that ability is called as polarizability. Okay, so this is what we need to understand about the polarizing power and polarizability. Now, what are the factors which are dependent for the polarizing power? So generally we are talking about this cation. Okay, so I hope that this may take more time to explain, but let us try to understand very simply. Okay, there is nothing to be worried about this topic. It is very simple. Now what is polarizability? Polarizing power of a cation. The polarizing power of a cation depends upon the first point. It depends upon the size of a atom. Yes. How can this happen? Let us say, for example, let me talk about LiCl and NaCl. Okay. So these two are some ionic compounds where lithium is a smaller size atom, sodium is a 11 electron atom, and if you draw the structure of this particular like say this one LiCl, okay, and if I draw this for NaCl, see, you can see some difference in the size of an atom. So you know that when the distance between this cation and anion is very less, the charge, the polarizing power of the cation is more. Why? Because they are very close each other. But if you see here in NaCl, the size of atom is somewhat bigger compared with lithium. So here also polarizing power is there, but the polarizing power when compared with lithium, it is very less in case of NaCl. Why this means? Because of the size of an atom. Very simple. Okay, because a lean person can run fast, a fat person cannot run fast. When size of a person increases, the energy decreases. That's the same thing. So the polarizing power of a cation depends upon the size of an atom. For example, there is a question regarding the polarizing power in the examination, asking that LiCl and NaCl, find out which is having more polarizing power. Then you can answer that LiCl is having more polarizable power, and this is the first thing. Okay, the next one is the charge of atom. The charge of atom. Okay, when more number of charges is increasing in a cation, then the polarizing power increases. Now let us see. For example, okay, let us say there are 2 electrons here. When this particular 3 electrons here, okay, when there is one particular atom is losing one electron, then means it will getting a positive charge here, okay? Which means now before losing one electron, before getting the positive charge, I mean the cation property, there are 3 electrons, which means the nucleus in this particular atom is now showing its attraction towards the 3 electrons, okay? But when it loses one electron here, when it loses one electron, there are 2 electrons only here now, which means now there is a space for nucleus to show more attraction towards 2 electrons. To summarize this, if we compare the force of attraction between nucleus over the electrons in case of the first case, which means there are 3 electrons in the first case, the force of attraction when we compare with that 3 electrons with this 2 electrons, the force of attraction here is more. Why? Because there are less number of electrons, which means 1 plus here more. Before plus charge, before plus the electron, the force of attraction between nucleus and electron is less. After 1 plus, it is more. After losing 2 electrons, now guess, it is more. Yes, very simple. Okay, so when it is increasing more, then the extent of the polarizing power increases. Polarizing power increases so that this cation can pull more number of electrons towards the cation from the anion, which means it can distort the anion. I hope you are clear now. So this is about the charge of an atom. And the third point here is pseudo inert gas configuration. Okay, now we are going to end it very quickly. Next one is pseudo inert gas configuration. Okay, so we all know that inert gas configuration is 8 electrons. Okay, so outermost electrons are 8, and if you say that pseudo inert gas configuration, it means that the outermost electrons may consist 18 electrons. For example, if you take Cu plus, okay, Zn plus, these are having the pseudo inert gas configuration. Those particular cations which contain pseudo inert gas configuration are said to be as more polarized. Okay, so this is, they are having more polarizing power. Okay, for example, if you take Cu plus, so we can write like 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. This is the exact configuration of copper. But if it is losing 1 electron, so the outermost electron will lose 1 electron, where you can see 10 plus 6 plus 2, 18 electrons. So if there is a question like this, KCl and CuCl, find out which is having more polarizing power. Means then generally we know that the two cations are same, sorry, 2 anions are same. But in case of cations, generally the students may do one small mistake here is, depending upon the size of an atom, the potassium is very less when compared with copper. So they generally choose KCl instead of CuCl. But the thing you need to keep more important here is the Cu plus is having the pseudo gas inert gas configuration. Okay, so this is about polarizing power is dependent upon these properties. Now polarizability of anion. Polarizability. So now same here. The first one is size of atom. Okay. When for this is for anion. Okay. So this is the property of an anion. The polarizability is generally talks about the property of an anion, which means the first property, the factor, depends on the size of an atom. Okay. So if we say this, larger the size of an anion, large anion, which means large atomic size, big atomic size, then the polarizability is more and the covalent character is more. Now let me talk about this one particular thing. See, what happens here? If the size of an atom is big in case of anions, okay? If it is big, the distance between nucleus and electron is more far, which means the nucleus cannot have such effect towards the electrons. If the electrons is now freely available, what happens if I say there is a cation next to it? Okay, now the cation is less in size now, so it is having more polarizable power. Okay, no polarizing power. So what happens if it is large in size for the anion, and if it is small in size in case of cation, the polarizing power is more for cation, and in case of this particular thing, the polarizability case is more in case of anion, so it will pull the electron. So for this particular thing, in case of anion, we need to come to understand that the size of atom increases for anion, the polarizability increases, and the covalent character also increases for the ionic compound. For example, fluorine, bromine and iodine. If you say that here fluorine is the smallest atom when compared with these halogens, so that is how the covalent character increases, or the covalent character is more in case of ionic. Okay, more in case for iodine. Covalent character is more in case for iodine, because iodine is bigger molecule. It is a bigger molecule when compared with chlorine and bromine and fluorine. Okay, so that is what fluorine is less covalent with chlorine, and chlorine is less covalent with bromine, and bromine is less covalent with iodine. On what basis I am talking? On basis of the size of an atom. Okay, now second one. Here the charge. Now see, how do positive charge, the negative charge gets? By addition of gaining of electrons, right? You know that gaining of electrons, because chlorine accepts that one electron from sodium, so chlorine gains negative charge, which is anionic property. So if we say one electron here, okay, in case of chlorine only I am talking, okay, there is one electron needed for chlorine. Okay? So this is, let us say, the outermost shell, only one electron is there, which means the nucleus shows more attraction. But if electrons are going on increasing, what happens, What happens here? The extent of the nucleus charge over the electrons decreases. What happens? Obviously, when charge is increasing, which means minus is going on increasing. Okay, when minus is going on increasing, what does this minus indicate? It indicates the addition of electrons. Okay, when addition of electrons, negative charge increases. We know that. Okay, so this happens. When this happens, what happens? The electrons are far, which means the nuclear charge over that electrons is somewhat decreased. Why? Because let us say in a class there are 100 number of students, only one teacher cannot have focus on all everybody. Okay, but there is only one student in the class. How focused we are? That's it. So the nucleus, when electrons are increasing, what happens? The charge decreases. So for this conclusion, what we say? So when charge increases, the polarizability of polarizability of the anion increases, and so covalent character, this EC indicates covalent character. Okay, the covalent character increases. So this is about the polarizability of anion. So I hope you can now, let me simply summarize this with a shortcut, nothing but SCLA. To understand FAJAN's rule in one simple statement, SCLA. What is SCLA? SCLA is nothing but smaller cation, okay, large anion. That's it. One simple statement. SCLA. What is that? Smaller the cation, larger the anion, then the covalent character of ionic compound increases. As we know that, let us say one small example, and this is what a diagrammatical representation. When smaller cation, more polarizing power, larger cation, more polarizability for anion, what happens? So this small cation will pull the electrons towards the cation and the covalent character nature increases. Okay, so this is how about the FAJAN story. Now let us talk about some questions which can be expected like coming to this JEE and NEET. Okay, the first question. Okay, NaCl, KCl, RbCl. Now they will asking that among these, find out which is having more covalent character. Find out more covalent character. Which is more covalent. So very simple. First you need to check all the cations and anions first. So you can see that all the anions are same. Okay. But if you see about the cations, they are different. Now what students? What is the simple thing here is, see the size of the cations. Okay. As we know that polarizability increases, so polarizing power increases for cation, the covalent character increases for an ionic compound. Here, the among here all this particular compound, the having the smallest atom is sodium. So that NaCl is greater than KCl, which is greater than rubidium Cl. Okay. This is how the question comes. Now, next question. Next question. Let us say some next question. How can a questions come according to this topic? Like NaCl, MgCl2 and AlN3. Find out which is more covalent. Now find out which is more covalent. Here, if you see that this question is based upon the charge. Here one charge, here 2 charge and here 3 charge. Okay? Yes? 1 chlorine 1 charge, 2 chlorine 2 charge, 3 and nitrogens 3 charges. We know that when charge increases, what happens? The covalent character increases. So if you write that AlN3 is greater in covalent character with MgCl2, because MgCl stands with the 2 charges. We cannot write NaCl here. Even though Na is smaller in size, but what happens here? Charge is increasing means now the size of atom doesn't matter here. Okay? When charge is increasing, the more power will be there. So how much big is the atom? When there is only 1 electron, the charge of the nucleus is more, na? So that is how. Okay? So that now NaCl. So this is how we can also get according to this topic. Now next question. CaCl, ZnCl. CaCl and ZnCl. Okay, CaCl. Now find out which is more covalent character. You can also, they can also like ask like which is more ionic also. Now we'll see. Now if you see that calcium has 20. Okay. So here the calcium exhibits inert gas configuration. Generally we say that calcium is 20, zinc is 30. Here anions are same, but calcium and zinc, when we compare, the size of atom is less in case of calcium, but in case of zinc it is more. So obviously we say that CaCl is greater than ZnCl in case of covalent character. Okay, but the thing is here, Zn is having pseudo inert gas configuration. Okay, how? So Zn 30. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Here it is 2 electrons, 2 chlorines means it is Zn plus 2. So okay. So here you can say 10 plus 8, 18 electrons are present here. So we know that pseudo gas inert configuration also depends upon the polarizing power for the cation. So you can generally say that yes, calcium is less atom, zinc is 30, so there is very vast difference between the size of atom. Generally you put CaCl, but that is not the case here. The question is regarding about the pseudo inert gas configuration. So if any question comes on the question paper, you need to check whether all the 3 points. First you need to go with the size, next you will go with the charge, and next you must go with the what we say, the pseudo unit gas control. Then last question. So now this question is from NEET 2005. Okay, this question is from 2005. Like there is a question asking like a NaCl and LiCl and BeCl2. There is a question asking that write the correct sequence regarding the covalent character. Write the correct sequence for covalent character for the given compound. If you see, now let us find out whether it is correct sequence or not. Okay, this question is from 2005. Okay, 2005 question. Every year you may be asking one question from FAJAN route. Okay, now let us find out. All anions are same. Okay, so there is no confusion. But when we talk about the cations, there are different cations. Out of this, the least one is lithium, next beryllium and sodium. Generally, the size of atoms depends upon the polarizing power. Na? So we say that Li comes first, LiCl. Next, now beryllium, BeCl. Yes, BeCl. Sorry. Next comes the NaCl. Depending upon the size of atom. Now, if you look at very importantly here beryllium is having +2. Okay. Now we know that when there is charge increasing, no matter the size of atom, the charge will now take the part for the polarizing power. So if you write, now it will not be in the second position, it will be in the first position because BeCl2 has +2 charge. And as usually, we write LiCl and then NaCl. So if you write for covalent character, we can write like this. BeCl is more covalent than LiCl and more covalent than NaCl. In case of ionic character, if the question is like asking the correct sequence for ionic character, then you may need to write larger anion. So if you say that, if you write about the ionic character, so large cation here, this is large cation. So NaCl comes first. Then comes the LiCl. Then comes BeCl. Okay. So this is how the questions may be coming in the FAJAN stream. Okay. So this is how about the FAJAN stream. Okay. I hope you understand this topic, and very important topic for your JEE and NEET. So I hope you are very much clear. Practice some questions and you can get this particular important topics. Thank you.